Number 1 is factored form, number 2 is vertex form, and number 3 is standard form. So the factored form will look something like this. Y equals to x plus or minus p times x plus or minus q. And here p and q are the roots, are the x-intercepts of the parabola. X-axis 2 times means at y equals to 0, it crosses 2 times, okay? So this p and q are the value at which the curve cuts the x-axis. And for the vertex form, it will be y equals to a x minus h the whole square plus k, where h and k are the coordinates of the vertex, where this h is the x value and k is the y value of which the curve forms a vertex. And for this curve, as we already know that this is the vertex and the coordinates of the vertex is 2, 1. So here the h value is 2 and k value is 1. And for the standard form, it is ax squared plus bx plus c equals to 0, okay? Where this a and this a are same, and it is called the shape factor. And this shape factor will determine whether the parabola is upward or downward. And this b is the coefficient of the linear term, and this c is the constant, or it is the y-intercept. Y-intercept means it is a point at which the curve crosses or cuts the y-axis, and coordinates will be 0, y value. So for this above curve, we know that at 0, negative 3, this point, the curve cuts the y-axis. So the y-intercept is negative 3 in this graph. Now let me tell about 2 types of parabola and why it is important. Generally, there are 2 types of parabola. Number 1 is upward parabola and number 2 is downward parabola. The upward parabola will look something like this, and downward parabola will be like this. And how will we know this? If we draw arrows like this on the tip of the curve, and when both of the arrows are pointing upward, it is called upward parabola, and when they are pointing downward, it is called the downward parabola, okay? And for our above curve, it is downward parabola, okay? Therefore, this shape factor said earlier that if a is greater than 0, which means a is positive, then it will describe the upward parabola. But if the a is less than 0, which means a is negative, then it will describe the downward parabola. With this information, now we are sure of one thing, that for this curve, the a value should be less than 1, should be negative something t squared. Now with all these concepts, let's find out the equation of the curve above. And for this, as vertex is given, y-intercept is given, roots are given, it will be better if we find the equation in this form, which is vertex form. So here h k value is 2, positive 1, and y-intercept value, where 0, y value is negative 3. And we should also know any exact points which the curve passes. And here in this curve, we know many points. Like here, it passes to 0, 3. Here, it passes through 1, 0. Here, 2, 1. Here, 3, 0. And here, 3, negative 3. So let's use point 0, negative 3, which is this y-intercept point, okay? With this information, now we have y equals to a x minus h whole square plus k. And we know the h value, k value, and we know x value here, y value here for this point to find the value of a. And the value of a should be less than 0 or negative. Therefore, we can write y equals to a x minus 2 whole square plus 1. Okay, and for this, let me tell you something. If h value is greater than 0, which is positive, then we can use directly the value here, which means here h is 2, so I have used h is 2. But if h is less than 0, which is in negative value, then you should reverse the sign, which h is, for example, if it is negative 2, then when you put it here in this equation, then it will become a x plus 2 whole square plus k, something like that. Okay, so you should keep in mind. But here the value is positive, so we can directly use 2 here. Now, to find a value of a, we can substitute any point which the curve passes, and here we will use 0, negative 3. So when you use this, we will get negative 3 is a 0 minus 2 whole square plus 1, which is negative 3 4a plus 1, which is a equals to negative 4 by 4, which is negative 1. So now as this negative 1 is less than 0, okay, it is negative, therefore now it seems that we are getting the equation for the downward parabola that we have already discussed. Now the vertex form of the equation will be y equals to negative 1 x minus 2 whole square plus 1. Okay, so this is the equation of the curve. Finally we got the equation of the curve. Okay, now from here we can also expand this term to get in a standard form. Now to expand this from vertex to standard form, all we will need to do is just to expand this expression. Okay, so we can expand like this: negative x squared minus 4 x plus 4 plus 1 equals to 0, because I've expanded this using a minus b the whole squared, which is a squared minus 2ab plus b squared. Okay, now it will be negative x squared, negative is positive for x, and see here it will be negative positive is negative, negative 4 plus 1 is negative 3 equals to 0. So this is the standard form of the equation. Okay, now as per the question, here the variable is t here, so we can just replace this x with t. So the equation of the above curve, this curve will be x t equals to negative t minus 2 whole square plus 1, or xt equals to negative t squared plus 4t minus 3 equals to 0. So if you factorize this equation to make in this form, then you will get t equals to 1 and t equals to 3, because you know that from this curve the value of x-intercepts are 1 and 3. Now at last we got the expression for the particle's position, or the function which describes the curve. Okay, now as we have determined the value of the particle's position with respect to time with the function of t, now we can answer the remaining questions, which is b, c and t. To do that, now we have vt, instantaneous velocity, is derivative of the particle's position with respect to time. So now we will just need to differentiate this equation that we have found to find the expression for the instantaneous velocity. So to do that, we will have vt equals to d upon dt negative t squared plus 4t minus 3, okay, which will be 2t plus 4.